Everyone, this is one another question for complex analysis that was asked in CSIR NET September 2022, and it's like some basic real analysis question. We can think very basic way. So, what is the question actually? So, we given that if n denotes the nth derivative of f, and actually we can, since the function is defined on entire function, it's no need to worry about that whether it is a complex valued function or not. It's just we can exclude this entireness. Except of entireness, we can think only the function c2 function that is satisfying this condition f2 plus f equals to 0. So before going to solve this question, I just want to observe the options first. It's better to, since you are in some competitive exam, it's better to discard the option. Yeah, it's obvious that one should explain the proper way in every question. It is better to do in home, but for in exam hall, once there is some objective question, one can approach it in discard method. Right? That is, you must have some example by which you can discard the three options, and the rest of one or two will be your correct answer. So here, if we choose fz equal to cos z, you know that this cos z function is entire function. Entire means analytic throughout on C. So here fn z, what is the fn z? We can observe that if we derivative f one times, this will be minus sin z, f double times, this will be minus cos z, f third time, that will be sin z, f fourth time, that will be cos z. Now this is our cycle, because fz is f fourth derivative will be same as fz. So fn z is cos z for n equal to 4k, and sin z n equal to 4k minus 1, minus cos z n equal to, or one can write it as plus 1 also, 4k plus 2, sorry, that will be 4k plus 2, and minus sin z n equal to 4k plus 3. Am I right? No, I did mistake here. Something. Okay. Okay. This will be sin z, I think. Yeah. 2. It's okay. So it will be minus. So so at z equal to 0, we can easily observe that fn 0, this sequence will be 1 0 minus 1 0, and this. So it's obvious that this is an oscillatory sequence. The image of the sequence is actually 1 0 minus 1 0. The range is containing only 3 elements, 0 1 minus 1. So this is not a converging function. So first option is wrong, second option is something same. It's both 1 and 2 are same actually. First and second options are actually same. One can do in same way. So even though C also. So A, B, C, three options will cut by this process. Now f2 plus f equal to 0. So once we consider this as it's a second degree function, second degree homogeneous, second degree linear differential equation. So what will be the solution for this equation? fz equal to c1 cos z plus c2 sin z. Those who are not able to understand how it will come, For that case, I am going to just give the idea, the auxiliary equation. Here will be m square plus 1 equal to 0. I think you now can understand how it comes. M equal to plus minus I. From there we write this as a solution. So similarly, if we derivative fn at z, it is somehow some linear combination of cos z and sin z, right? Isn't it? So nth derivative of z, because we derivative f n times means cos z will be derivative n times, sin z also going to be derivative n times. So nth derivative of fn, nth derivative of f, that is f n z, is linear combination, some linear combination of cos z and sin z. So let's say it is d1 cos z and d2 sin z. Therefore fn at 0 is nothing but d1. Yeah. So what will be its modulus? Modulus will be these things. Now it's a finite number, so modulus of fn 0, if we choose a sequence, this is a real sequence and bounded. So once we have a real sequence and bounded, then by which theorem? Bolzano-Weierstrass theorem. fn 0 has a convergent subsequence. We have our answer as this is our required answer. Okay, goodbye.